Hi, everybody. This is going to be the topic for our classwork in week 4, and it's going to expand on continuity, and we're going to be looking at, it's going to expand on limits, and we're going to be looking at continuity. Okay. So there'll be a couple of questions there towards the end of this particular screencast and Edpuzzle. So here's what we talked about a little bit last week. We talked about the difference in a function limit and a function value. So for example, the difference in the limit as x approaches 3 of h of x versus evaluating h of x. This is a y value. This is an approaching y value. It's a prediction. So we have these two graphs over here. There's one very, very small difference. This first graph has a hole at 3. This second graph still has a hole at 3, but it also has a function value. And we did talk about this last week. Given the function g of x at the right, does the limit exist? And if so, evaluate it. And so let me zoom in here. Actually, I'm going to pop in a multiple choice question for you. So what is the limit as x approaches 3 of g of x? Okay, first multiple choice question. Okay, so in fact, yes, the limit did exist. And what you would do is you would look at it from 3 from the positive side. You look at both one-sided limits, 3 from the negative side. So this would be my positive direction. If I'm a ladybug, I think I'm going to land at 2. If I come in from the left side, the negative side of the graph, I'm a ladybug. I still think I'm going to land at 2. It doesn't matter that it's an open circle. So we have a value of a limit of 2. So if you got that wrong on this, the question, I would go ahead and ask me to reset this Edpuzzle because now you could definitely get it right. Okay, and before we move on to part B, let's go ahead and evaluate the function value. So does g of 3 exist? And so since I have an open circle here and I don't have any solids, I have to say that it does not exist. Or you can say undefined. We have a hole in the graph at 3. So now we look down at h of x, and again, we evaluate the limit. So we look at it from both directions. It's the same exact graph, but we have this function value now, and that exists at 2. H of 3 exists at 3. And does the value of the function, does the actual value affect the limit? So we can have functions, limits and function values that are not equal to each other. And when this is the case, 2 is not equal to 3, this graph has a point of discontinuity. So at 3, at x equals 3, this graph is considered discontinuous. Or you would say it is not continuous. So how do we formally define continuous? Well, there are 3 parts to this. Oops. The formal definition of continuity applies to any given point on the graph. All 3 of these conditions must be met. All 3 must be satisfied, or the graph is not continuous at that particular point. So going back to this example here, g of x, this graph and h of x. So h of x at x equals 3 was not continuous. But at every other point on the graph, if I wanted to evaluate the limit at 1, so I would say the limit of h of x as x approaches 1, look at both sides, we're approaching 0. The function value there is 0. And since this condition is equal to that condition, since 0 equals 0, these are the 3 conditions we would have to meet. So at x equals 0, this graph is continuous. So you can kind of use some logic there and see that it's continuous everywhere except we have that hole. Or it would be continuous everywhere except where we had maybe a vertical asymptote. Okay, so we can do these first 2 in any order, but we need both of these in order to figure out the third one. So for any point C, so for example, x equals 3 or x equals 0. So for any point C, if the function exists, there's an actual value. you're good. If the limit exists, that says exist. And if those two things are in fact equal to each other, then the graph is continuous. And again, be sure you understand that it's all three. All right, so I'm going to do a couple of examples, give you a quiz question, and then review graphing piecewise functions, because that's some of the classwork you'll be doing next week as well. So the first value we're going to look at is -4, right here. So I'm going to go ahead and go in this order. So condition 1, f of -4. Does it exist? Yes, it does. It exists at this point here, which happens to be 3. Does the limit, let's call this function f of x, exist as x approaches -4? Remember, you have to look at left side. So from the left, it's equal to 3. From the right, it's equal to -2. So this limit does not exist. So not continuous. You don't even have to look at the third condition because all three have to exist. And if I just got it does not exist right there, I'm done. It's not continuous there. You can also think back to the very informal definition. Functions are continuous if you don't have to pick up your pencil. So here we would have to pick up our pencil and continue. But now we're looking at continuity at one point. I'm not saying is the entire graph continuous. I'm saying at a very specific point is the graph continuous. So this graph is continuous in other places, but at -4, we would have to jump to the second part. But we have to now look at all three conditions and state them. Okay, so let's look at x equals -1. All right, first condition, does f of -1 exist? And if so, what is it? So what is the function value at -1? It is 4. And that is a filled in circle. Here are my opens. Okay, does the limit exist as x approaches -1? Okay, we come in to -1 from both sides. Both my ladybugs land at a y value of 4. Because 4 is equal to 4, condition 1 is equal to condition 2, this graph is continuous at that point. X equals -1. Finally, let's look at condition at x equals +4. So I come in. Now I'm going to do the limit statement first. The limit as x approaches 4. Well, remember, open holes and open circles don't matter. My ladybugs are coming in. They both think they're going to meet up at a y value of 2. But if I evaluate the function there, f of 4, well, it's an open circle, and I'm looking all over here, and I don't see any filled in circles. So this does not exist. So I didn't even have to do that part. Once one condition is not met, you're good. Okay, so these are going to be your 2 questions. So this is going to be your first 2 multiple choice questions. This graph is only going to exist here. And this is the graph we looked at last week in class. So filled in, open, open. This is solid. All right. So the first multiple choice question, is the graph continuous at 10? And I'm going to ask you to state why. Or why not? Your second question, and make sure you write these down and you have to maybe take a screenshot of this graph so you don't have to watch the video again. Is the graph continuous at -8? Why or why not? And again, really think about all 3 of these conditions. So you have to find out, does the function exist? Does the limit exist? And are those 2 things equal to each other? Okay. Moving on. just want to review graphing piecewise functions because you're going to have to start doing this again. Okay, this indicates that f of x is two things. It's quadratic for part of the graph and it's linear for part of the graph. And I'm going to ask you questions on continuity. Okay, so what I do is I plug the value in. So basically this is my important point right here. It's where my graph turns from quadratic to linear. Sometimes those points coincide on a y value, sometimes they're disconnected. So 2x plus 1 for x is greater than 1. So I'm going to plug 1 in. And I get 3. So I'm going to graph this point 1, 3. But it's an open, oh, and it's a filled in circle, sorry. Filled in circle. And I'm going to do that for all x's less than 1. This is not what I wanted to do. Sorry, kiddos. Did my inequalities backwards. So I'm going to go up to and over 1 additional point. And that can be pretty much a sketch. We just know it's linear. For all x's greater than or equal to 1, it's linear. And then I've got this quadratic that's shifted down 3 units. But again, I'm going to plug 1 in. 1 squared minus 3 is -2. So I have this point 1, -2. 1, -2. That's going to be an open circle because it's just less than. And I know this is just a downshift. So this graph is going to look like this. So that's just a review of graphing piecewise functions. So if I stated, is this graph continuous at x equals 0? You would say, okay, does f of 0 exist? Yes. Which function is it? Just look at your graph. It's on this part right here. F of 0 is -3. We don't care about the line. You can't say f of 0 is -3 and 1 because this graph only exists for x is greater than or equal to 1. So that would be a total mistake. Does the limit of f of x exist as you approach 0? Well, come in, you hop down to the other graph, and you're approaching a y value of 0. I mean, -3, geez. Condition 1, condition 2, does -3 equal -3? Yes, it does. It's continuous. So if I asked you to tell me, is this graph continuous at x equals 1? Well, I want to do all my conditions again. What is f of 1? Well, this is an open circle, so it's not quadratic. It's going to be this value here. F of 1 is on this linear part of the graph. F of 1 equals +3. 2, does the limit of f of x exist as x approaches 1? Well, you got to look at it from the positive side. You got to look at it from the negative side. Coming in, your 2 ladybugs. Positive one thinks they're going to land at 3. The negative side thinks they're going to land at -2. So this limit does not exist. And so it is not continuous at x equals 1. So graphs, these are points of continuity. So at this one particular place at x equals 1, this graph is discontinuous. It's not continuous. It is continuous everywhere else on this function. So without me doing this graph for you, I'm going to ask you, let me see if I can find my notes. -2x and x squared minus 3 for x is greater than, I kept doing all my inequalities backwards, or equal to 1. So I just changed the linear part. And my x squared minus 3 is less than 1. So just as a hint, it's going to be this exact parabola, but the linear function is going to change. And the linear is only going to be from 1 and over. So this side will be linear. And from here over, this side will be your quadratic. Okay, is this graph continuous at x equals 1? And I'm going to ask you to state whether all three conditions are met. And that's the last multiple choice question. All right, I'll see you in class for week 4 classwork. The classwork is not going to focus on exponentials. That's going to be an on your own. The classwork will focus on continuing with limits and adding this idea of continuity. Thank you.